this is your Kalpana. Today in this video we are going to see integration with variable limits. Okay. Integration with variable limits. So here the first thing is limits are variable limits. Limits are variable limits. Okay. And second one, the order of integration depends on variable limits. Okay, limits must be variable limits and order of integration depends on variable limits. Okay, suppose I equals to double integral x1 to x2 and integral y1 to y2 function of x comma y into dx dy. Okay, if we consider this integral, x1, x2 are arbitrary constants. Whereas y1 and y2 are functions of x. y1 and y2 are functions of x. That is, y1 equals to f1 of x and y2 is equals to f2 of x. Okay. So, order of integration always depends on variable limits. Okay. So, this implies I equals to integral x1 to x2, which are constants, and integral y1 equals to f1 of x and y2 is equals to f2 of x into function of x comma y, since you're having variable limit y. Okay, so you'll write dy first, differential dy into dx. Okay, first you'll evaluate for y and then you'll go for x. Let's see some problems. First one, evaluate integral 0 to 1, integral x to root x, xy, dy into dx. Here you can notice that the limits are in x. That is f1 of x and f2 of x. This one will be your f1x and f2x, which is equals to x, which is equals to root x. Function of x is y, 1, y, 2. Okay. These are constants. So, x1 equals to 0, x2 equals to 1. Okay. Solution. Let I equals to integral x1 equals to 0, x2 equals to 1, integral y1 equals to f1 of x equals to x, y2 is equals to f2 of x equals to root x into, since this is in y, so you'll get dy first, xy into dy into dx. So this is equals to integral x equals to 0 to 1. So I'll write for x and y simply. Okay. Into integral y is equals to x2 root x into, since this is in y, so y into dy into x dx. Okay. Since we are integrating with respect to y, so x will be a constant. So I'm taking it here. Okay. This is equals to integral x equals to 0 to 1 into, you know that since integral x power n dx is equals to x power n plus 1 by n plus 1 plus c. So you can use this formula here for y. So you'll get y square by 2 under limits y equals to x to root x into x dx. Okay. So this is equals to integral x equals to 0 to 1. Now apply the limits. Upper limit y equals to root x and lower limit y equals to x. You can write like this if you want. Now it will be clear. Root x whole square by 2 minus x square by 2 into x dx, which is equals to integral x equals to 0 to 1 into x by 2 minus x square by 2 into x dx. Okay. So now we can multiply the whole thing with x. So what you'll get? This is equals to integral x equals to 0 to 1 into 1 by 2. Take 1 by 2 as constant. Take it out. 1 by 2 into integral x equals to 0 to 1 into x minus x square. X minus x square into x into dx. Now multiply this. This is equals to 1 by 2 into integral x equals to 0 to 1 into x into x square minus x square into x is x cube into dx. So this is equals to 1 by 2 into integral x square. What is integral x square? X cube by 3 minus x power 4 by 4. Under the limits, x equals to 0 to x equals to 1. Since integral x power n dx is equals to x power n plus 1 by n plus 1 plus c. You have used the formula here. Okay. So this is equals to 1 by 2 into, first apply the upper limit, 1 by 3 minus 1 by 4 minus of lower limit, 0 by 3 is 0 minus again 0 by 4 is 0. This is equals to 1 by 2 into 1 by 3 minus 1 by 4. So take LCM. 3 4s are 12. So 1 by 2 into 12. 3 4s are 12. So 4 minus 4 3s are 12. So this is equals to 1 by 2 into 1 by 12. So this is equals to 1 by 2 into 12 is 24. Okay. Therefore, integral 0 to 1 into integral x to root x, xy into dy dx is equals to 1 by 24. Okay. So next problem. Next problem, second one. Valued integral 0 to 2, integral 1 to e power x, dy dx. Limits must be variable limits and order of integration depending on variable limits. I equals to, limits must be variable limits, e power x. So this is function of y. Function of x, which is equals to y. E power x and 1. y2 equals to f2 of x, function of x. This is also function of x. You'll take it as y1. And this one, x1 equals to 0, x2 equals to 2. Okay. Now, let I equals to integral, these are constants. So, x1 equals to 0, x2 equals to 2. And integral y1 equals to f1 of x equals to 1. y2 equals to f2 of x equals to e power x into, this is for y, so dy, and next we'll write dx. So this is equals to x1 equals to, right, for x equals to 0 to 2 into integral y equals to 1 to e power x into dy into dx. So this is equals to integral x equals to 0 to 2 into integral dy is y into, under the limits, y equals to 1 to y equals to e power x into dx. Okay, since integral dy is equals to y plus c. So this is equals to integral x equals to 0 to 2. Now apply the limits for y, e power x minus 1 into dx. Since integral e power x dx is equals to e power x, so this is equals to integral x equals to 0 to 2 e power x dx minus integral x equals to 0 to 2 dx. Also you have integral dx is equals to x. So this is equals to e power x minus x. Under the limits, x equals to 0 to 2. So which is equals to e power 2 minus 2 minus, now apply the lower limit. First you have applied upper limit and next you will apply lower limit, that is 0. E power 0 minus 0. Since e power 0 is equals to 1, this is equals to e power 2 minus 2 minus 1 minus 0. So this equals to e power 2 minus 2 minus 1, which is equals to e power 2 minus 3. Minus 2 minus 1 is 3. Minus 3. This is your answer. Therefore, integral 0 to 2, integral 1 to e power x, dy into dx is equals to e power 2 minus 3. Okay, fine. So this is all for now. Hope you all understood. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye bye.